Hello everyone, welcome to Programming Knowledge. I again welcome you all to Programming Knowledge. This is the second tutorial of a new series that is getting started with competitive coding and DS algo. Basically we are going to continue with number theory. That is, in this tutorial we are going to cover all divisors of a number in root n complexity and prime number checking. That is going to be primarily test in root n complexity. So this is going to be interesting. Let's get started with this. So this is a primary test basically. So I'll tell you the difference, how you can create the difference, that how is it different from others. So basically here we are going to do a primarily test. So then before that we are going to check the divisors of a number, but the difference here, we are going to do both of them in root and complexity. So that means, in root and complexity means, I'll show you an example and you'll get it how we are going to do that. So let's get started. I'll open my files. I'll open my files here. Yeah. On the left, I'll produce the output, and on the right, I will code. Okay, so I'll save this file. Okay, let me move to my desktop. Yeah. So first I'll do divisors.py. So I'll quickly take like I have a number 24. So I have all the divisors of it. So divisors of 24 is equal to 1 comma 2 comma uh, 4 is the divisor. Yes. 6 is a divisor. Yes. 24 is a divisor. Yes. I am missing two numbers, that is 3 and the next is going to be 8. Yeah, so I guess all these are the divisors. Even 12 is also a divisor. Yeah, so here you can see that here you can see 1 2 is a divisor, 3 is a divisor, 4, then 6, then 8, then 12 and 24. Yeah, so I'll take an input. T is equal to input. So how many test cases I'm going to be taking, then while t is equal to t minus 1, then I'll take n is equal to input. Okay, and there here I'm going to define div is equal to uh, uh, fun1 of n, and then I'll do print star div. Yeah, then I'll do div2 is equal to fun2 of n, then I'll do print star of div2. Yeah, so I'll define a function here, define div1. So here you can see div1, sorry, fun1 of n. So here you can see for I in range 1 to n plus 1. Okay, then div1 is equal to div1 is an empty list for I in range 1 to n plus 1. If n modulo I is equal to 0, then div1 dot append I, but here you can see then I would return div1. But here you can see the time complexity of this program is big O of n, because I am making a for loop from 1 till n. So here I can write like this, 1 to n. I'm making a for loop of 1 to n, but I can write an efficient program where define fun2. I can write an efficient program where time complexity is equal to root of n. That is root of n. So this could be more efficient. For that I'll do div2 is equal to set. Okay, then for I in range, here I will loop till loop only. Let me import an header file from math, import star. Okay, then for I in range, int sqrt square root of n plus 1. So I can see that I'm making a for loop till 1 to root n. Yes, perfectly fine. I'm making a for loop to 1 till root n. Then div2 dot add Okay, let me type if condition. If n modulo I is equal to 0, then div2 dot add I and div2 dot add n by I also. I'll tell you the trick here. Return div2. Okay, so let me first run this program. So I'll define it as return list. Then I would type this set to a list. First it was a set, but now I have typecast to this to a list, and now I will return the program. Okay, so let me run the program. I'll give it test case 1, then 24. Okay. Let me. I'm having an error. Okay, yeah. So div1 has to be there, and then yeah, then 1 and 24. Yeah, here you can see from both the here you can see like both the programs run return the list of divisors, but one in a time complexity of on and then one a time complexity of root n. So basically for just for an example, here you can see, so you can maybe you can see like uh, that n is equal to 24. So one time complexity would be is equal to O of n. So that would be equal to 24. And for time n is equal to 24, time complexity is equal to root n. So basically here you can say that root n is nearly equal to, let me have a calculation that how much root n is equal to. So here you can see, yeah, root n is equal to 4.89 because root 25 is equal to 5. So here you can see that how much difference does it make. Okay, so here you can see that. So I would tell you the trick here. Here the trick was the analogy here. Here you can see that if you could divide the integer by 1, then if you could divide the integer by 1, then 24 divided by 1 is equal to 24. You can keep at the right side. Then if it is divisible by 2, then 24 by 2 is equal to 12. Okay, I'm making an inside, I'm making a move from both the extreme ends. Then if it is divisible by 3, then you can do 24 divided by 3. 24 divided by 3 is equal to 8. In the same way, here you can do 1, 24, 2, 12, 3, 8, and in the same way 4, then 24 by 4 is equal to 6. So here in this way you can make an efficient program as compared to, because here you can say that root n is a efficient program. Okay, if it is an efficient program, because and the time complexity of O of n is greater than, or here you can see that it is greater than root of n, or you can say that time complexity of root n is less than n. So here you can make an efficient move in the both the ways, and this is a very shorthand syntax. If you want to print a list of, let me show you that if I have a list A is equal to 1, 2, 3, 4, 5. Okay, and if I do for I in range, this is a new trick. For I in range 0 to len print a of I and is equal to this. So here you can see then you can print in a space separated manner. So you get 1, 2, 3, 4, 5. But I can do this in a one single line by doing this print star a. So here you can see that you can use this amount of line of code into a single line, and this might be an efficient, while if you want to print a large list, so this would keep you at a very efficient program. So this was a good learning process. So we'll catch up in the next tutorial. So thank you guys, thank you so much. I'll catch up in the next tutorial. Thank you guys.